Hey guys, Mr. Volpe here. Let's all start with something that I know we're all comfortable with, right? I know we've all heard and seen this word coefficient before in the sign of our times. Everybody all stressed out figured we'd start with something I know we know, right? So coefficient, I hope you're already thinking it's just that number in the front. So for example, the coefficient of this first guy is 4, right? All right, is there a coefficient here in number 2? Well, there's no large number in front or anything, but if we all remember, there is a 1 that's in front of there, so there might be a coefficient of 1. How about number 3? Now that you're getting the hang of it, just take a quick sec, think about it. Hope you got it. Coefficient of 2, right? And then the same thing with number 4. Thinking about it, seeing a negative something or another right here in front of this, and so then maybe there's a coefficient of -1, right? Awesome. Comfortable with coefficients. I apologize because I know that has very little to do with the rest of the stuff, but again, I thought we'd just do a short little warm-up, just reviewing something in case we ever got back to school. All right, let's move to the new slide, new material here. So do your best. Take notes. Grab a note sheet, grab a binder, or whatever it is you guys are going to do now that you're at home all the time. Write some of this down, or of course you have this video all the time so you can just come back to it. But here's the next slide. Monomials. The new word of the day for us is going to be monomials. Of course it says here what it is, right? It's a number, a variable, or a product of numbers and variables. Don't let that freak you out. That just means a number and a variable that's multiplied, and there it is, right? The -7 is being multiplied by the x. So don't let the fancy words freak you out. All right, here's some examples of monomials. Monomial, right? Mono, one kind of a thing. So this is one thing, one whole pairing, another whole pairing, another thing over here. I know that's one whole pairing, but it does say this whole number exponents is what it has to have. And I know you guys know this. I know we were working on this -2 business. That means that x would have to become x squared down below, kind of like this x cubed is over here. That means that this exponent is not a whole number. This 4 is a whole number. This one with the -2 would not be a whole number. So this is not a monomial. This here is a pairing of two things, 4x and this -y, if you will. So that's two things. That's not one. Mono meaning kind of one thing. And then we have this guy here is clearly not a whole number because it's a fraction. If I wrote it out, it would actually be something like 2x to the -3rd, right? And then I'd have to pull that down. So that's not a whole number exponent, so it doesn't count. All right, that being said, here's our job. Our job is to find a degree of our monomial. This will help us to number things and name them later on. You've already been graphing them with me, so you guys have been doing an awesome job with all of that. But now we're going to give them some names. So this is a degree, first and foremost, for the first day or so, few days. We're going to just give them a degree. And it says, is the sum of the exponents. If you can add, you can do this. Here we go. A constant has a degree of 0. Just for an example on that, all that means is 3. The degree there would be 0. Or if I had 10. The degree there would be 0. Anything, a constant, that's anything with just a number, just a whole number like that without any variables. So there's no variables with those two numbers, the 3 and the 10, right? All right, next screen, we'll give you some examples and we'll be done. There we go. So I remember the monomial said it is the sum of the exponents on the variables. So I have two variables here, p and q. They have exponents of 4 and 3, so I am just going to add those. 4 and 3 is 7, so the degree here is 7. That's it. We're going to use that later on, but for right now, let's just focus on what is a degree, and a degree is that, 7. This one over here, we have an e and a d, right, are our variables, and they don't have any numbers. So I'm sort of stumped. I'm like, no numbers. What do I do? All right, wait a second. I think there is a 1 here and a 1 here, correct? So if I add those, 1 plus 1 is 2. So So the degree here is 2. Nothing to it. Last but not least over here, we have this monomial of 3. That was the same as the example I gave previous, right? That's a constant. There is no variable here. So there's nothing to add to something else. There's nothing to notice. It's just a degree of, and I hope you already said it, a degree of 0. So just to recap, I'm going to ask you in the next few days to find a degree of your monomial, right? It says so right here. And all we had to do was add the exponents for the variables. So 4 plus 3, 7. 1 plus 1, 2. Degree of 2. We didn't do anything with the 7, and we did nothing with the 4. Just added those exponents with the variables. All right, guys, take care. Bye.